Hello, 6th graders. Welcome to Big Ideas Math, Contract Math, Section 9.4, 2012 edition, Independent and Dependent Events lesson. Pause while you write Section 9.4, 2012 edition lesson in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is compute theoretical probabilities of dependent and independent events. Copy the following key terms, definitions, and examples exactly as they appear into your notebook. Independent events are two events such that the occurrence of one event does not affect the likelihood that the other event will occur. Dependent events are two events such that the occurrence of one effect affects the likelihood that the other event will occur. Today we'll be starting on page 406 in your math textbook. Example 1, identifying independent and dependent events. Tell whether the events are independent or dependent and explain. Letter A, you flip heads on one coin and tails on another coin. The outcome of flipping one coin does not affect the outcome of flipping the other coin. So, the events are independent. So if one event does not affect the other, then they are independent. Letter B, your teacher chooses one student to lead a group and then chooses another student to lead another group. The teacher cannot pick the same student to lead both groups, so there are fewer students to choose from when the leader of the second group is chosen. So the events are dependent. Take a minute to write this key idea in your notes, the probability of independent events. The probability of two independent events, A and B, is the probability of A times the probability of B. So in symbols, it looks like capital P parentheses A and B equals P parentheses A times P parentheses B. So be sure you write the whole thing in words and the whole thing in symbols in your math notebook because you'll need that. Moving on to page 407, example 2, finding the probability of independent events. You flip two quarters. What is the probability that you flip two heads? So method 1, you use a tree diagram to find the probability. So we're going to use H to stand for heads and T to stand for tails. So the first flip, if we get H, we put an H here, and a T, we'll put a T. So the first flip, we have H or T, and then the second flip, regardless of whether we flipped heads or tails, we can flip a heads or a tails on the second flip. So that would give us a combination of heads heads or heads tails. And that would be for the first flip, or we could have a combination of tails heads or tails tails. So the probability of two heads is the number of times two heads occurs out of the total number of possible outcomes. So there's one way for two heads to occur, and there are four total number of outcomes. So there's one way for two heads to occur out of all of these four outcomes. So four total outcomes. So 1 out of 4. So the probability that you flip two heads is 1 out of 4, or 25%, if you want to put it as a percent. Method 2, we can use the formula that we just wrote down. The probability of A and B is the probability of A times the probability of B. So the probability of heads and heads equals the probability of heads times the probability of heads. So if we look up at our tree diagram, we know that the probability of flipping heads on the first flip is 1/2. And the probability of flipping heads on our second flip is also 1/2. So we have 1/2 times 1/2, and that equals 1/4. So the probability that you flip 2 heads is equal to 1/4. Now we're going to move on to page 408. Take a minute and write the key idea at the top of this page, the probability of dependent events. The probability of 2 dependent events, A and B, is the probability of A times the probability of B after A occurs. So that's what makes the difference between independent and dependent. So it's written as P parentheses A and B equals capital P parentheses A times capital P B after A. So be sure you write all of that in your notes. Example 3. Finding the probability of dependent events. You randomly choose a flower from the vase to take home. Your friend randomly chooses another flower from the vase to take home. What is the probability that you choose a purple flower and your friend chooses a yellow flower? Choosing a flower changes the number of flowers left in the vase, so the events are dependent. So there are 7 purple flowers. So we're looking at the probability of the first flower chosen being purple. And there are 7 purple flowers, and there are 28 flowers altogether. We're getting this information not from trying to count them in the picture, but from the information that is next to the picture. So it tells us that there are 7 purple, and if we add them all up, we get 28 total. So there are 7 purple, total of 28, that equals 1/4. And the probability that the second is yellow, there are 9 flowers, and then on the second draw, there are only 27 flowers in the vase because your friend just took one. So that gives us 1/3. So we're going to use the formula to find the probability. So the probability of A and B equals probability of A times the probability of B after A. So the probability of purple and yellow equals the probability of purple times the probability of yellow after purple. So when we substitute in the numbers that we got from up here, we get 1/4 times 1/3, which equals 1/12. So the probability of choosing a purple flower and then a yellow flower is 1/12, or about 8%. Your assignment for this lesson is to complete the On Your Own problems 1 through 5 below. They're also on pages 406 through 408 in your textbook. Show your work and be prepared to share during our next class. Please remember, to earn credit for viewing this flipped lesson, you must complete your exit slip, come to our next class prepared with the journal pages or other work from the flipped lesson completed, and be prepared with any work that was assigned in the flipped lesson completed. Be prepared with any questions you have for the teacher, and always have a good attitude. We'll see you next time in class.